Okay, these are some more problems from section 6.2, and this is number 37, and this is the sine of 2t plus 1 over the cosine squared of 2t plus 1 dt, and we can use some trig identities to help us with this one. And what we can do is we can break this up into the sine over the cosine, sine of 2t plus 1 over the cosine of 2t plus 1, times 1 over the cosine of 2t plus 1. And the sine over the cosine is the tangent, and 1 over the cosine is the secant. So we got secant tangent. We know that the derivative of the secant is the secant times the tangent, so that would lead us to want to set it up like this. So I'm going to let u equal 2t plus 1. So I've got the tangent of u, 2t plus 1 is u, times the secant of u, dt. And I want to get a du there. So what I'll do is I'll take the derivative of 2t dt, and I get 2 dt. So du equals 2 dt, but I just want a dt, so I'll divide both sides by 2. And I have du over 2 equals dt. Now I just reverse those by using the commutative property of multiplication, so I could have secant tangent, so that looks a little bit more like our formula. The derivative of the secant is the secant tangent, or on page 332, the antiderivative of the secant tangent is the secant. And we've got the du over 2, so I'll take the, so these were a match, so I substitute it here, and then I take the 2 in the bottom out as 1/2, so I've got 1/2, the secant u, tangent u, du, and this is just exactly like I have it on page 332, and the antiderivative of that is just the secant of u plus c, and I have 1/2 that, and that I just substitute, and u is going to be 2t plus 1, so that's what we have. Now there's another way to do that using the power rule. But this is a little bit easier. This gets a lot of the work done in the trig identity, so it makes the work a little bit easier as we finish it up. Okay. I may show that alternate method later. Okay, here's number 39. So we've got du over x natural log of x. And this is the same thing. I can break this up into 1 over the natural log of x, all right, times 1 over x dx. Now the reason why I did that, because what's the derivative of the natural log of x? 1 over x. It looks like I've got the derivative of this over here, so it looks like I could maybe think of this as 1 over u du. Now this is a little bit odd because we haven't seen this many logs, but it works out. So I rewrote this as 1 over the natural log of x times 1 over x dx, and this looks like, again, like I said, 1 over u, and the derivative of this is that. So I let u equal the natural log of x, so this is going to be 1 over u times this, and then I want to find du, I don't want dx, or 1 over x, so I'll let u equal the natural log of x, I'm sorry, since I let u equal the natural log of x, du will be the derivative of that, which is just 1 over x dx, and see, I've got a perfect match here. So this ends up being the antiderivative of 1 over u du, and on 332 that says the antiderivative of this is the natural log of the absolute value of u plus c, and that just equals the natural log, and what was u? The natural log of x, so I've got the natural log of the natural log of x plus c. Okay, so that's a little tricky, but it works out. Hope you can make sense of that.